Welcome to PeakGuard, intelligent energy forecasting built for real operations. In the next few minutes, you'll see how our platform turns raw IoT sensor data into clear, actionable predictions so teams can anticipate demand, control costs, and move confidently toward sustainability. PeakGuard is a modern, fast API service that simulates device-level energy signals and serves accurate next-hour forecasts. Under the hood, we run a device-aware synthetic stream aligned to each device's time zone and persist readings in SQLite for repeatable evaluation. Every hour, background schedulers append new readings, run the deployed model, and store the next hour prediction. Each day, we compute health metrics like RMSE, MAPE, bias, and an at-a-glance drift status, so you always know how the model is behaving. Why it matters. Instead of reacting to spikes after the bill arrives, PeakGuard helps you see them coming, shift loads, and avoid penalties. The stack is intentionally lean, a secure API, a responsive Plotly.js interface, and a lightweight database, easy to deploy locally or in the cloud. From factories and campuses to smart buildings, the outcome is the same: better decisions, lower waste, and a clearer path to net zero operations. Let's look at the GRU-RNN that powers PeakGuard. We begin with basic EDA, plotting hourly consumption, comparing day-night patterns, and smoothing with moving averages to reveal weekly rhythm and anomalies. Next, we frame the data as sequences. The model consumes the last 48 hours and predicts the very next hour, a tight operational horizon where accuracy matters. The network is compact and purpose-built, a GRU layer to capture temporal dependencies, dropout for regularization, and dense layers to map features to a single kW prediction. We normalize inputs with a min-max scaler and track a full set of training diagnostics: training loss, validation loss, and validation RMSE in kilowatt hours. You'll see those curves flatten as learning rate schedules step down, a sign the model is converging rather than memorizing. For deployment resilience, we export both a full Keras model file and a weights-only checkpoint. If environments drift, for example, TensorFlow or Keras versions differ, the API reconstructs the architecture and loads the weights fallback so the service stays online. That reliability is critical when predictions inform live operational decisions. Now to the live demo. The app focuses on three simple, powerful components. First, real-time readings. A scrolling list of the latest 24 entries, newest last, so you can sanity check the signal at a glance. Second, the KA forecast plot. A blue line for the last 24 hours of history, and a connected green segment marking the next hour prediction. Remember, the chart shows 24 hours, but the model actually reasons over 48 hours of context to make that single-step forecast. Third, model monitoring. RMSE, MAPE, and bias, plus a drift status flag that flips when error ratios pass thresholds. A simple, reliable early warning. We also surface training diagnostics, validation loss, training loss, and validation RMSE, with quick plots so you can compare offline training behavior with live performance. Here's the flow. On load, the app fetches API devices, then calls API synthetic latest device ID for the recent window, and post API forecast for the next point. It refreshes every hour or whenever you reload the page, so forecasts and health indicators stay current. PeakGuard is designed to be clear for operators and transparent for data teams, a practical bridge between IoT sensing and trustworthy AI forecasting, built to help you forecast smarter, act faster, and save more.